The series RL circuit we'll discuss today. The series RL circuit is a circuit containing a resistor and an inductor which are connected in series with a battery. Okay, so consider a resistor and an inductor which are connected in series with a battery, that is called as series RL circuit. Okay, so what happens if battery is switched on? When battery is switched on, the current through the circuit takes time to become steady. So in case of resistor, the current will become immediately steady. The resistor will carry the constant current. But what happens in case of inductor? Due to the electromagnetic induction, it will oppose the incoming current. So when battery is switched on, the current will slowly increase. It will not increase immediately. It will slowly increase. Because of that, you can observe the transient phenomena. So that is because of the phenomena, or because in accordance with the Leges law, which states that the direction of induced current is opposite to the inducing current. Okay. So in inductor, the induced current is going to be developed, and that will oppose the incoming current or inducing current. This opposition does not allow the current to become steady instantly, but the current starts to increase in the RL circuit slowly. So slow agi current increase ಆಗ್ತದೆ. So that is observed in RL circuit. So in capacitor, in RC circuit, what is going to happen? Charge is going to increase slowly. ಅಲ್ಲಿ charge increase ಆಗ್ತದೆ capacitor ಅಲ್ಲಿ. In case of inductor, the current is going to increase slowly. Here current is going to show the transient phenomena. You remember this. So similarly, during the break of the circuit, either switch on ಮಾಡಿದಾಗ current slow ಆಗಿ increase ಆಗ್ತದೆ ಅಂತ ಆಯ್ತು. What happens if battery is suddenly switched off? Then the current decreases in a short time because of the opposing induced EMF in the inductor. According to Leges law, again, if current is switched off, if battery is switched off, the inductor will oppose the decrease in current. Because of that, the current decreases slowly. It will not decrease suddenly, but it will decrease slowly in a particular short interval of time. Because of that, during the switching on of the circuit and during switching off of the circuit, the transient phenomena of current is going to be observed. So when battery is switched on, we call it as growth of current. So current is growing, current is increasing. When battery is suddenly switched off, in case of RL circuit, we call the decreasing current as a decay of current. Okay, decay of current ಅಂತ ಹೇಳ್ತೇವೆ. ಎರಡು ಕೇಸಸ್ ಅನ್ನು ನಾವು ಸ್ಟಡಿ ಮಾಡಬೇಕು. So when battery is switched on, how does the current grows? So how growth of current takes place? Ondadu. Another one, if the battery is switched off, when maximum current is flowing through the inductor, when battery is switched off, the decay of current is going to take place. Decay means decrease. Decay of current is going to take place. How does the decay of current takes place? We have to analyze that also. So two cases will arrive. So today we'll consider the growth of current case. Okay, growth of current and what consider now. Let us take the case of growth of current. So let us consider a resistor of resistance R, an inductor of self-inductance L is connected to a battery of EMF E. It is a simple circuit. A resistor of resistance R and an inductor of L, self-inductance L, is connected to a battery through a certain switch. This can be used to switch on the circuit and switch off the circuit. So initially, there is no current before switching on. Before closing the switch, there is no current, and current is going to increase slowly. What happens? At the instant the switch is closed, the current start to flow through the series combination of R and L, and induced EMF develops in the opposite direction. Current start to flow through the circuit, and but this inductor will induce the current which will oppose the incoming current. Idu opposite direction li current anna produce ಮಾಡ್ತದೆ. Because of that, this current will not become steady immediately. It will slowly increase. Okay, it opposes the growth of current and allows the current to increase slowly. So induced EMF ಏನ್ ಮಾಡ್ತದೆ? that will oppose the incoming current. Because of that, the current will increase slowly. So let us consider capital I be the instantaneous current through the circuit, which is a function of time, because current changes with the time. Slowly it will increase. So I be the instantaneous current at any time t, and small e be the induced EMF, which depends on the rate of variation of current through it. We know that voltage across the inductor is given by minus L into di by dt. Okay, that is the expression for voltage across the inductor. So let us find out what is the expression for I. How does the current changes in the circuit, in the series RLC circuit, when switch is closed? Okay, so let us start with the analysis. Let us apply the Kirchhoff's voltage law to this circuit. A battery is there, EMF E, and the voltage across the resistor is I into R. Voltage across the inductor is minus L into di by dt. What is di by dt? Di by dt is variation of current, where minus L into di by dt gives the voltage across the inductor. Already I have discussed that in one of the previous classes. Now apply the KVL to the circuit. At the instant the switch is closed. Okay, ಆ time ಅಲ್ಲಿ ನೀವು ಯಾವ ತರ equation ಬರಿಬಹುದು ಇಲ್ಲಿ? That means when the circuit is closed. So that is given by E, that is the voltage of the battery, minus voltage across the resistance, that is IR, minus voltage across the inductance. Okay, that is minus L into di by dt. This negative sign comes because of the fact that the induced EMF is opposite to the battery voltage. So this is the first equation we have to take. Now we have to solve this equation for I. So this is a first order differential equation. We have to integrate this equation and we have to find what is the expression for I finally. Finally, ನಮಗೆ ಏನು ಬೇಕು? Expression for current ಬೇಕು ನಮಗೆ. Okay. First order differential equation ಇದೆ ಅದು. First you have to separate the variables. Variable separation ಮಾಡಿ integration ಮಾಡು. Let us do that one by one. We'll take solving. So let us solve this equation to separate the variables. I will keep this IR on the one side. IR will be equal to E minus L into di by dt. ಈ IR ಅನ್ನು ಮತ್ತೊಂದು ಕಡೆ ತಗೋತಾನೆ. ನಿಮಗೆ I into R equal to E minus L into di by dt. In the next step, you find the expression for I. I will be equal to E by R minus L by R into di by dt. So you have to divide this equation throughout by R. So R cancel ಆಗ್ತದೆ. You will left with I here. On right hand side, you will have E by R minus L by R into di by dt. So further solve this. You will get to separate the variables, you collect the terms containing I to the one side and other terms on the other side. I will take this E by R to the other side. You will get I minus E by R equal to minus L by R into di by dt. Okay. ಅಂದ್ರೆ ಈ I ಇರುವಂತ ಟರ್ಮ್ ಅಲ್ಲ ಒಂದ್ ಕಡೆ ತಗೋಬೇಕು, T ಇರುವಂತ ಟರ್ಮ್ ಅಲ್ಲ ಮತ್ತೊಂದ್ ಕಡೆ ತಗೋಬೇಕು. So let us do that. Now this is the equation we have got. I minus E by R equal to minus L by R into di by dt. Then separate the variables. So you will get cross multiplication ಮಾಡ್ರಿ. You will get the di by I minus E by R. So di by I minus E by R ಇದು ಇಲ್ಲಿ ಬರ್ತದೆ, equal to minus R by L into dt. Okay, you got this particular step. So separation of variables. I ಇರುವಂತ ಟರ್ಮ್ ಅಲ್ಲ ಒಂದ್ ಸೈಡ್ ತಗೋಬೇಕು, ಉಳಿದಿದ್ದ ಟರ್ಮ್ ಅಲ್ಲ ಮತ್ತೊಂದ್ ಕಡೆ ತಗೋಬೇಕು. ಸೊ I ಇರುವಂತ ಟರ್ಮ್ ಯಾವುದು? I minus E by R. You take this to other side. ಈ minus L by R into dt ಅನ್ನ ಮತ್ತೊಂದ್ ಕಡೆ ತಗೊಳ್ರಿ. It will become minus R by L into dt. Okay. In the notes I have given each and every step. You just go through that also. So step by step we will solve further. This separation of variable is done. You look at this term. This is the term containing only I, where E is constant, R is constant, resistance of the resistor is constant, battery potential or battery voltage is constant. On the other side, R is constant, L is constant, dt is the variable. I ಇರುವಂತ ಟರ್ಮ್ ಅನ್ನು ನಾವು ಒಂದು ಕಡೆ ತಗೊಂಡೇವೆ. Next you integrate this. Integrate this one. So this is the integration with respect to I. On the other side, integration is with respect to time t. So you will get integration of di by I minus E by R equal to minus integration of r by L into dt. Okay, so methods are derivation steps are almost same. Series RC circuit allu same irtada, series RL circuit allu almost same irtade ನಿಮಗೆ. Okay, ಏನಂದ್ರೆ ಫಸ್ಟ್ ಕಿರ್ಚಾಫ್ಸ್ ವೋಲ್ಟೇಜ್ ಅಪ್ಲೈ ಮಾಡೋದು, then you have to solve the equation, separate the variables, then do the integration, and finally you will get the logarithmic equation ಸಿಗ್ತದೆ ನಿಮಗೆ. You convert that logarithmic equation into exponential equation, you will get the final answer. Okay, so these are the major steps. So what is the integration of this di by I minus e by r? This is 1 by I minus e by r formula ಇದೆ. So 1 by I minus e by r integration is log of I minus e by r. Okay, ln of I minus e by r, where ln means log to the base e. That is equal to r by L is constant, integration of dt is t, plus some integration constant c. Okay, because it is an indefinite integral, limits hakilla, that's why integration constant c will get. So to find the integration constant c, you put the initial conditions when t equal to 0, that is just before closing the switch. What was the current I? I was 0. ನೀವು ಬ್ಯಾಟ್ರಿ ಸ್ವಿಚ್ ಆನ್ ಮಾಡೋಕ್ಕಿಂತ ಮುಂಚೆ ಕರೆಂಟ್ 0 ಇರ್ತದೆ. So to determine the value of c, put the initial conditions. That is, when t equal to 0, then I should be equal to 0. When t is 0, I is 0. Put t equal to 0 here, I equal to 0 here. What you will get? You will get c is equal to ln of minus e by r ಬರ್ತದೆ. We get c is equal to ln of minus e by r, because I is 0, t is 0. So substitute this value of c in this equation. Illi substitute ಮಾಡಿ. Substituting ln of I minus e by r as it is equal to minus r by L into t. Okay, as it is. C ಗೆ ಏನು ಮಾಡಬೇಕು? Substitute ಮಾಡೋದು. What is the value of c? C is ln of minus e by r. So ln of minus e by r is substituted here. Then solve this to find the expression for I. Our aim is to find the expression for I. Take this term to the other side. So you will get ln of I minus e by r minus ln of minus e by r. This has to be taken other side, equal to minus r by L into t. Okay, ಇದನ್ನ ಈ ಕಡೆ ತಗೊಂಡಿದ್ದೀನಿ. This is of the form ln of m minus ln of n. So that is given by ln of m by n. Okay, so solving ln of I minus e by r divided by minus of e by r ಆಗ್ತದೆ. So this divided by this, ln of this term divided by this term, that is equal to minus r by L into t. So take this r as a LCM, you will get IR minus E divided by minus E by R. R gets cancelled, R cancel ಆಗ್ತದೆ. You will get IR minus E divided by minus E. R cancel ಆಗ್ತದೆ. Okay, ಇಲ್ಲಿ ಮೇಲ್ಗಡೆ ಏನು ಮಾಡಬೇಕು? You take the LCM as R, you will get IR minus E whole divided by R ಬರ್ತದೆ. That R will cancel with this R. ಇಲ್ಲಿ upper numerator ಅಲ್ಲಿ IR minus E ಉಳಿತದೆ, denominator ಅಲ್ಲಿ minus E ಉಳಿತದೆ. So this is the logarithmic equation. ಇದು logarithmic equation. ಇದನ್ನು ನೀವು ಏನು ಮಾಡಬೇಕು? Exponential form ಗೆ ಬರಿಬೇಕು. Okay, so next step. This is the equation you have got. ಈ equation ಬಂತು previous slide ಅಲ್ಲಿ. Next, that is, you write this equation in the form of exponential form. Already I have told you, if ln of m is equal to x ಅಂತಿದ್ರೆ, then m will be equal to e to the power x. So m, that is IR minus E divided by minus E, is equal to e to the power minus r by L into t. ಇದು exponential form ಗೆ ಬಂತು. Next is mathematical steps to solve the I. Finally, we need expression for I. Take this minus e to the other side. So you will get IR minus E is equal to minus E into e to the power minus r by L into t. Simply, ಇದನ್ನು cross multiplication ಮಾಡೋದು. Take this e to the other side. You will get IR is equal to E minus E into e to the power minus r by L into t. Okay. Then take r to the other side. That is, E is common factor. You will get I will be equal to E divided by r into 1 minus e to the power minus r by L into t. What is this E by R? E is the battery voltage divided by resistance. V by R iddange, voltage by resistance iddange. That is actually maximum current, and we call it as I naught. E by R ಗೆ I naught anta karitare, where I naught is the E by R. It is the maximum steady current through the circuit after certain time. The above equation gives you the instantaneous current through the RL circuit, which is given by I is equal to I naught into 1 minus e to the power minus R by L into T. So this is the equation representing the instantaneous value of current. When T is 0, so T is 0 ಆದರೆ ಏನಾಗ್ತದೆ ನೋಡ್ರಿ, e to the power 0, which is 1, 1 minus 1 is 0. So I will be 0. So that is the initial condition. Before closing the switch, when T is 0, I should be 0. When this T becomes infinity, when T is very large, this will become e to the power minus infinity. E to the power minus infinity is 1 by e to the power infinity. 1 by e to the power infinity is 0. So then I will be equal to I naught. Okay, andre current will become maximum after large time, after long time. Okay, so this is how the exponential growth of current is observed. Next, we'll analyze that. So according to this equation, I equal to I naught into 1 minus e to the power minus R by L into T, the growth of current to I naught is exponential. 0 ದಿಂದ I naught reach ಆಗೋದು, exponentially it will increase. This is the graph. So current versus time ನೀವು plot ಮಾಡಿದ್ರೆ exactly ನಿಮಗೆ ಈ ತರ exponential curve ಬರ್ತದೆ, which is same as the charge on the capacitor in RC circuit. RC circuit ಅಲ್ಲಿ ಯಾವ ತರ equation ಬರ್ತದೆ ಅದೇ ಬರ್ತದೆ, but here that nature is observed for current. RC circuit ಅಲ್ಲಿ the nature is observed for charge, but here it is observed for current. Similar to that, during time T is equal to L by R. Suppose T equal to L by R anta substitute ಮಾಡ್ರಿ, you will get R gets cancelled, L gets cancelled. T is equal to L by R. Okay, then current through the circuit is given by I equal to I naught into 1 minus e to the power minus 1 ಆಗ್ತದೆ. ಇದು ಕ್ಯಾನ್ಸಲ್ ಆಗ್ತದೆ, e to the power minus 1. We know that 1 minus e to the power minus 1 is 0.63. So this will become 0.63 times I naught. So current will become 63% of the maximum when T is equal to L by R. Okay, sorry, ಇದು R by L ಅಂತ ಆಗಿದೆ, ಇದು L by R ಆಗಬೇಕು. Okay, sorry, I have to correct it. So this L by R is called as the time constant of RL circuit. Remember, in RC circuit ಅಲ್ಲಿ time constant ಯಾವುದು? It is R into C. Resistance into capacitance is the time constant. In RL circuit, L by R is the time constant. Okay, L by R is the time constant. You remember this. L by R is the time constant. So this time constant is in RL circuit is defined as the time during which the current rises to 0.63 times that of the final steady current through the circuit. Andre 0.63 times of the I naught. ಆಗ್ಲಿಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ಬೇಕಲ್ಲ, that time is called as the time constant. ಇಷ್ಟು ಕರೆಂಟ್ ಆಗ್ಲಿಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ಬೇಕು? This is the time. Okay, so this, therefore, the value of L by R decides the rate of growth of current in the circuit. So how fast the current increases in the circuit is decided by the value of L by R. If L by R is larger, it takes a long time to increase the current. If L by R is smaller, so by fastly the current increases. Okay, quickly the current grows in the circuit if L by R is very small. Okay, ಇದು ಕಡಿಮೆ ಇತ್ತಂದ್ರೆ ಫಾಸ್ಟ್ ಆಗಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ, ಇದು ಜಾಸ್ತಿ ಇತ್ತಂದ್ರೆ ಸ್ಲೋ ಆಗಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ. Okay, that is how you can understand the concept of the growth of current in RL circuit. Okay, so just I will recall the derivation once again so that you can understand it properly.